5. Towards green energy. Use of various energy sources, generation of electrical energy, process of generation of electricity and environment. Can you recall? 1. What is energy? 2. What are different types of energy? 3. What are different forms of energy? Let's discuss. Make a list of the work that we do in our day-to-day life using energy. Which forms of energy do we use to do this work? Discuss with your friends. Energy and use of energy. In modern civilization, energy has become a primary need along with food, clothes, and shelter. We need energy in different forms for diverse types of works. The energy that we need may be in the form of mechanical energy, chemical energy, sound energy, light energy, or heat energy. How do we get these different forms of energy? Make a table. Make a table based on forms of energy and corresponding devices. We know that energy can be converted from one form to another. Different sources of energy are used to the different forms of energy necessary for us. In previous standards, we have learnt about energy, sources of energy, and various concepts related to them. Here we will learn about various sources that are now used for the generation of electrical energy, the methods that are used for this, the scientific principles that are used there, the advantages and disadvantages of these methods, and also what is meant by green energy. Can you tell? 1. Where do we use electrical energy in our day-to-day life? 2. How electric energy is produced? Generation of electrical energy. Most of the electric power plants are based on the principle of electromagnetic induction invented by Michael Faraday. According to this principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. The field around a conductor can be changed in two ways. If a conductor is stationary and magnet is rotating, the field around the conductor changes, or if a magnet is stationary but the conductor is moving, then also the field around the conductor will change. Thus, in both these cases, a potential difference is created across the conductor. The electrical power generating machine based on this principle is called electric generator. Such large generators are used in commercial power generation plants. Turbine is used to rotate the magnet in the generator. A turbine has blades. When a flow of liquid or gas is directed on the blades of the turbine, it rotates. See figure because of the kinetic energy of the flow. This turbine is connected to electric generator. Thus, the magnet in the electric generator starts rotating and electric energy is produced. Schematic of electric generator. This method of electric energy generation can be represented as below. Thus, to generate electricity based on the principle of electromagnetic induction, we need a generator. To rotate the generator, we need a turbine. And to drive the turbine, we need an energy source. Based on which type of energy source is used to rotate the turbine? There are different types of power generating stations. The design of the turbine used in different types of power stations is also different. Thermal energy based electric power station. In this, the turbine is rotated using steam. Water is heated in a boiler using the thermal energy released due to burning of coal. Steam of very high temperature and pressure is generated. The energy in the steam drives the turbine. Thus, the generator connected to the turbine rotates and electrical energy is produced. The steam is converted back into water and the water is recirculated to the boiler. This is shown in flow chart in figure. Flow chart showing generation of electrical energy using thermal energy. Fuel coal, boiler for conservation of water to steam, steam turbine, generator, electrical energy. System for converting steam back to water. Since thermal energy is used here to generate electrical energy, such power plants are called thermal power plants. In thermal power plants, the chemical energy in the coal is converted into electrical energy through several steps, which are shown in figure. Energy transformation in thermal power plant. Chemical energy in coal, thermal energy, kinetic energy in steam, kinetic energy in turbine, electrical energy. Let's think. 1. Why the energy in the coal is called as chemical energy? 2. Why steam is used to rotate the turbine? If you see a thermal power station, you will observe two types of towers there. What are they? If you observe the schematic of the thermal power station in figure, you will get answer to this question. Compare the schematic of thermal power station with the block diagram above and you will understand how the boiler, turbine, generator and the condenser are arranged in the power station. After combustion of fuel, here coal, in the boiler, the emitted gases are released to the atmosphere through very high tower. Once the turbine is rotated using the steam at high temperature and high pressure, steam temperature and pressure decreases. This steam is converted back to water by taking out heat from it, that is, by cooling it. This is done in the condenser using water in the cooling tower. The water in cooling tower is circulated through the condenser. Heat energy in the steam is given to the water and the steam condenses back to water. The heat absorbed by the water is then released to atmosphere through vapor and heated air through cooling tower. Although thermal power generation is a major way of electricity generation today, it suffers from certain problems. Use of ICT. Prepare a presentation about thermal power plant using computerized presentation, animation, video, pictures, etc. Send it to others and upload on YouTube. Problems. 1. Air pollution due to burning of coal. Burning of coal results in emission of gases like carbon dioxide, sulfur oxide and nitrogen oxide, which are harmful to the health. 2. Along with the emission of gases due to burning of coal, soot particles are also released into the environment. This may cause serious health problems related to the respiratory system. 3. The reserves of fuel used in this method, that is, coal, are limited. Therefore, in future, there will be limitations on the availability of the coal. Do you know some major thermal power plants in India and their capacity? Place, state, capacity, megawatt. Vindhyanagar, Madhya Pradesh, 4,760. Mundra, Gujarat, 4,620. Mundra, Gujarat, 4,000. Tamnar, Chhattisgarh, 3,400. Chandrapur, Maharashtra, 3,340. Power plant based on nuclear energy. In the power plant based on nuclear energy also, steam turbine is used to rotate the generator. However, here the energy released by fission of nuclei of atoms like uranium or plutonium is used to generate the steam of high temperature and high pressure. The energy in the steam rotates the turbine, which in turn drives the generator producing electricity. The flowchart of nuclear power plant is shown in figure. Nuclear power plant. Fuel, uranium or plutonium. Nuclear reactor for nuclear fission. System for steam generation from water. Steam turbine. Generator. Electrical energy. System for conversion of steam back into water. Thus, here nuclear energy is converted into thermal energy. Thermal energy is converted into kinetic energy of steam. Kinetic energy of steam is converted into kinetic energy of turbine, and finally, the kinetic energy of the turbine is converted into electrical energy. The step-by-step transformation of energy is shown in figure. Energy transformation in nuclear power plant. Nuclear energy, thermal energy, kinetic energy in steam, kinetic energy in turbine, electrical energy. Can you tell how does nuclear fission take place? When neutron is bombarded on atom of uranium-235, it absorbs the neutron and converts into its isotope uranium-236. Uranium-236, being extremely unstable, converts into atoms of barium and krypton through a process of fission, releasing 3 neutrons and 200 mega-electron-volts energy. The 3 neutrons generated in this process cause fission of 3 other uranium-235 atoms, releasing more energy. The neutrons released in this reaction release more energy through fission of more uranium nuclei. This process of fission of uranium-235 atoms continues and is called the chain reaction. In nuclear power plants, a controlled chain reaction results in release of thermal energy, which is used for electric energy generation. Internet is my friend. Complete the following table for some important nuclear power plants in India. Place, state, capacity, megawatt. Kundankulam, Tarapur, Rawatbhata, Kaiga. A nuclear power plant does not use fossil fuel like coal. Therefore, problems like air pollution do not arise. Also, if sufficient nuclear fuel is available, this can be a good source of electrical energy. However, there are few problems associated with nuclear power generation. Problems 1. The products after fission of nuclear fuel are also radioactive and emit harmful radiations. The products are called as nuclear waste. How to dispose the nuclear waste safely is a big challenge before the scientists. 2. An accident in nuclear power plant can be very fatal. This is because the accident may result in release of very harmful radiations. Observe the schematic of thermal power plant and the nuclear power plant. Discuss what are the similarities and differences between the two. Power generation plant based on energy of natural gas. In this plant, the turbine is run by a gas at very high temperature and pressure generated by combustion of natural gas. A flowchart showing various stages in the power generation plant based on natural gas energy is shown in figure. Arrangement in power plant based on energy of natural gas. Compressor for pressurized air, combustion chamber, gas turbine, generator, electrical energy. There are three main sections in this type of plant. Pressurized air is introduced into the combustion chamber using a compressor. In the combustion chamber, the natural gas burns in presence of the air. The gas at very high temperature and pressure generated in this chamber runs the turbine. The turbine then drives the generator to produce electricity. Step-by-step transformation of energy in this plant is shown in figure. Transformation of energy in power plant using energy of natural gas. Chemical energy in natural gas. Kinetic energy generated due to combustion of natural gas. Kinetic energy in turbine. Electrical energy. The efficiency of this type of power generation plant is higher than that of power generation plant based on coal. Moreover, since the natural gas does not contain sulfur, burning of natural gas results in less pollution. The schematic of power plant based on natural gas is given in figure. Schematic of power plant based on natural gas. Fuel, combustion chamber, gas turbine, emission of hot gases, generator, electrical energy. Let's think. Which electricity generation process is eco-friendly and which not? Some natural gas-based power plants and their capacity. Place, state, capacity, megawatt. Samral Kota, Andhra Pradesh, 2620. Anjanvel, Maharashtra, 2220. Bhavana, Delhi, 1500. Kondapalli, Andhra Pradesh, 1466. Always remember, though use of energy is unavoidable in our day-to-day life, it is necessary to use it carefully and only in the required amount. Electric energy generation and environment. Electricity generation based on fossil fuels like coal, natural gas and nuclear fuels like uranium and plutonium are not environment friendly. It means that if electrical energy is generated using these fuels, it can lead to environmental degradation. 1. We have seen that burning of fossil fuels like coal and natural gas leads to emission of certain gases and soot particles. This results in air pollution. Incomplete combustion of fuels leads to formation of carbon monoxide. It adversely affects our health. Increase in percentage of carbon dioxide in the air due to burning of fuels affects environment severely. The phenomena of global warming is an example of this. Nitrogen dioxide generated due to burning of fuels like coal, diesel, petrol, etc. lead to problems like acid rain. Soot particles generated due to incomplete burning of fossil fuel cause air pollution. It can lead to problems related to respiratory system like asthma. 2. It took millions of years for formation of fossil fuels like coal, crude oils and natural gases, LPG and CNG. Also, the reserves of these fuels are limited. They are going to deplete in future. It is said that with the current speed of their use, the coal reserves in the world would last for another about 200 years or so, and the natural gas reserves for about 200 to 300 years. 3. We have also discussed above about the problems in use of nuclear energy like the disposal of nuclear waste and possibility of disaster due to accident in nuclear power plant. Considering all these points, it can be said that the energy generation from fossil fuels and nuclear fuels are not environment friendly. Towards environment-friendly energy, towards green energy. There are other ways of electricity production which avoids above problems. Electricity generation from water reservoir, wind, sunlight, biofuels, etc. are the examples of such methods. The energy sources used in such options, that is, water reservoir, wind, sunlight, biofuel, are never ending, that is, are perpetual. Moreover, use of these sources do not lead to environmental problems discussed above. Therefore, electricity generation through these sources can be called environment friendly. We can also call the energy generated by these processes as green energy. Looking at the problems in electricity generation using fuels like coal, natural gas and nuclear fuels, the world is now heading towards environment-friendly energy, that is, green energy. Hydroelectric energy. Kinetic energy in flowing water or the potential energy in water reservoir is a conventional source of energy. In hydroelectric power plant, the potential energy in water stored in dam is converted into kinetic energy of water. Fast flowing is brought from the dam to the turbine at the bottom of the dam. The kinetic energy of the flowing water drives the turbine. The turbine in turn drives the generator to generate electricity. The block diagram showing different components of hydroelectric power plant is shown in figure. Different stages in hydroelectric power plant. Water reservoir with potential energy, water turbine, generator, electrical energy. Electricity generation using wind energy. potential energy in water, kinetic energy in flowing water, kinetic energy in turbine, electrical energy. Energy transformation in hydroelectric power plant. The schematic of hydroelectric plant is shown in figure. Water from about middle of the total height of the dam is taken to the turbine, as shown by point B in the diagram. Schematic of hydroelectric plant. A, B, C. Reservoir, wall, sluice gates, penstock, turbine, generator, powerhouse.